All right. All right, welcome to reverse engineering, our first reverse engineering meeting of the year. Ooh. If I can change this. Please. Oh yeah, okay. I clicked the wrong side, sorry. Okay, so we're gonna be playing BRICS plus CTF qualifier this weekend. We haven't played this one before. Hopefully it's good. Hopefully it's fun. We want you to come out and have a good time. We'll probably order pizza, so at least come out for that. All right. This is our flag for today's meeting. I'm gonna send Juniper into this one now. Yeah, here you go.
Testing.
You might have to. Well,
Testing. Oh,
all right.
okay.
So this for 5. There's camera in there, so just make sure to kind of project generally in that direction. Okay. And otherwise, you're good. If you want to feel my mic, you can. But if you're good with that one, I think it's just down. Okay. Yes, it's down. Apologies.
Sorry for the scuff. Welcome everyone to reverse engineering. That's flag. More on that later. Yeah. So as a brief preview, we have 2 sections of code here. I think we can all agree that the chunk on the left is easier to read and understand. So the overall goal of reverse engineering is to figure out what exactly the code is doing. Yeah. Since sometimes it's not easy to understand, maybe because of the way how it's written or like the algorithms used, or other times it's intentionally obfuscated. So there are multiple ways of approaching this. 2 main ways are static analysis and dynamic analysis. Static meaning that static meaning that we are not running the code, so we're only looking at the code or analyze the versions of it. Dynamic analysis is where we do run the code, or we can inject various things in order to see how the code or see the state of the program while it's running. So there are multiple abstraction levels where higher level languages are easier to understand and lower levels are harder to understand. So if we can convert from low level things to high level things, they're much easier to analyze and understand. So as an example of dynamic analysis, we have these inputs and outputs. Can anybody guess what the next output is? Any hands? Yes. Yes, the next output is
Trust us.
yes, trust us. The next output is 11. This is what the code looks like. We are taking the input and adding an increasing number to it, but sometimes it's not always possible to make such assumptions, or our assumptions might be wrong. So, for example, if the code looked like this, it might have a different output later on. So how do we do this reverse engineering? So for static analysis, some of the things we can do are rewriting functions or simplifying various pieces, especially if it's obfuscated. Renaming variables can be very helpful. For compiled binaries, we have tools like Ghidra, which will be covered in reverse engineering 2. Those will help with converting from machine level code to higher levels like C. So we have this code section here. Looks like we have a loop and some variables. We can simplify it to a for loop, but the order doesn't actually matter. So we can make it from 0 to 10. And in Python, we can simplify this further by list comprehension. So some of these are, for example, the first chunk is probably not the most useful. The last one is generally useful, but sometimes we might want like a slightly lower level. So which one is the most useful can vary depending on circumstance. For dynamic analysis, we can we can evaluate different parts of the code. If like you have a small chunk and you want to see what its value is, you can just run that directly. Or we can modify the program itself. Like if it's a Python file, then you could just modify it directly. Or if it's a binary file, you might have to patch it. So for patching and those kinds of things, you'd need debuggers like GDB. PDB is the Python version of GDB. Or some more advanced things would be like side channels, and these will be covered in the next meeting. So to go over a simple example, we have this chunk of code. It takes our input and tells us if it's the right or wrong. So yeah, we see here there's a for loop. And so we see that we're comparing the flag with some array. And you can try to just print it directly to see what the value is. It seems the value is flag. Or if we're unable to edit this file, we can run it in a REPL, and we can see what the value is that way. So yeah, that's it. Go solve challenges.
All right, so next Sunday, we're gonna be talking about, we're gonna give you a little bit of background in x86 assembly. So that's gonna be giving you the background you need for the next reverse engineering meeting, and also just teaching you what I think is a pretty useful skill, which is understanding assembly. And then next week, we're gonna be going over reverse engineering 2, which is going to go a lot more in depth on what we talked about today. Right. All right, go solve challenges. Make sure to put the meeting flag in, please. What's up?
This is for the OSINT ones, but the LinkedIn is programmed for the.
I still need to fix that. I'm so sorry.
Okay.
Yeah, that's my fault. Yeah, we'll be around to help you, so definitely, if you have any questions, raise your hand, and we can try to help out.
Basically, I sort of should.
You're asking to shut it.
I already know x86 assembly. It would be interesting scenario for scenario on the other side of so. Or the most used part of the development.
It's so funny, bro. Like, why is it
A lot
bit?
of
Wait,
come in.
it's crazy. And beyond that, it also is beyond just loading every register, right? It also loads Q1.
Sure.
So return that. And
That totally makes sense.
you control,
I
you
pursued
control for the next.
recreationally in
And
high
you
school.
control it
Because the
where
machine I had was an x86
And it's
machine,
often
and I wanted to do
like,
real
what the-
things. I wanted x86.
Like, you guys are dropping it.
Yeah,
Like, this is
have
like.
a strong background. I mean,
I'm
like,
working on trying to do a chain setup so that I can.
Oh,
the GL.
and that's why I'm so. No, but it's still so funny, like, totally, like, those, like. Laptop died. What's the, okay, for Risk Five, right, there was a Risk Five. I'm sure a lot of people got it. And because, like, I had the like right idea of what I was supposed to do, right, but I couldn't find the proper guide. For some reason I didn't see this one, which is like absolutely insane, because it loads like every register you can think of, like first four arguments, four arguments, and a bunch of other methods. And then it also returns what it loads return as a register. In risk five, like return as a and then it also loads T1 off of that. And this register is what
Use
these
use
ones are.
the predictor of that sometimes.
So with this guy,
Like
you
that,
can
that
control
like
where this button jumps to, like jump.
the when the projector.
So
flips
with
back,
further address
you
of
say
where.
No, that's a repetitive issue. It's just anything using H. I think it might be a projector.
Also.
It's happening.
So rather than broken that,
It's very jarring.
I wanted to make sure it was like a repetitive issue for our
I
text.
said,
Forgot to mention, if you need any help, please raise your hands when solving the challenges. Also, does anyone have any questions about the slides? Or does anyone want any clarification on things? Sounds good.
One of my friends works doing AV work for, so I was like, I was gonna ask them, hey, if you like this, you might want to check this out the next time you're working.
That's real. It's working, at least my software.
Very bad. I didn't remember it happening last year.
Fair, I,
explained this, right? The judge recommended. But, it will not explain the rest of it. How, like, do you read those or?
yeah, you just have to search object of. Yeah, it's in the.
Yeah, it says here apply.
It's in the list for this file. No, like this is a real, like,
Whenever you move like rules just like pseudo IPK, if you need to ban a certain item, like really quickly, it's like I want to like ban these items from this region after most of the use on it. That's really and ban just like it's like the actual like counting, you don't have that like this, like almost like all of them really feels first day. And spend more time on this fence. Context matters.
Yeah. I don't even worry. Or you can make this.
Those are mine. It's like.
If you want to do it now. Did you want to do it? Yeah.
No, I mean like
Yeah.
okay. Space time is kind of hard. Yeah. Others like there was one that was like. Yeah, running this on the machine. I didn't even look at that.
I did not mean to do that.
I think what's really.
Oh, so is this like a secondary display?
Yeah, it shows up as.
Oh, yeah, I was like, all the, I was like, I forget, it was like. Ones that have a local phone, yes. I like they're like, this one's super like. I don't know. It's like I don't know. Yeah. But the. Like everybody like. Are you the web one? Most of the web wasn't like that. Okay, but then like. There were. All of them, was like. Actually, one of them was like, it's like, that was the one that you didn't like. There was, like.
Hi, so I'm gonna be doing a demo of Python RE1 Easy Rev. And so the reason I'm doing this is that today's the first day I've seen the challenge. This is like kind of live in terms of like the thought process of how you would solve this. So the first thing with like any kind of rev is to just look at the binary and kind of read through it, maybe run it, and just sort of get a feel for what it's doing. So if we open up the binary here, or not the binary, the one we used to redraw. There's a couple of arrays with some numbers in them. There's this flag which also has some and some hex number. It's doing some operations here on encrypt1, encrypt2. There's this quiz function that asks you a bunch of questions, and then this is kind of what is actually running when you run this challenge. So it's going to call the quiz function. Quiz returns some number. It checks if this number is equal to some value, and then it does some computation, prints the flag. At this point, I would probably also run this binary and kind of verify my I guess understanding of what it does. So I would expect, if it's just nice to sort of in some sense like use a scientific method, have a hypothesis about what this program is doing, and try to verify it. So as expected, I'm asked a bunch of questions. I can like enter some stuff here that's not correct, and then I would expect that the program will print the flag. So yeah, no flag. At this point, we sort of understand the goal. The goal is I want quiz to return this number. One way to do this would of course be to try to figure out, like to try to enter values for all of these answers, since it's always adding to this core variable, enter a bunch of numbers that add up to score. Yeah, that's one valid solution, but something that we notice is that once quiz is called, the only thing that really matters is the value of n. Like all of these questions are kind of irrelevant. You have n, it's compared to something, and then all you care about is n. And you know that in the sort of correct n case, you already know the value of n. So, and this is a Python program, so it's very, very easy to fetch. You can just modify the source directly. So really what I want to know is I've got these operations here that do some computation on flag. They use n, so it's important that I have some correct value of n. But I already know what the correct value of n is. It is this value. So in fact, I can simply modify this program, just set n to this number and run it. And that will do the same as what would happen if I actually had the right answers to all of these questions. So essentially all I'm going to do is I'm going to say, instead of n being equal to quiz, n is now equal to this x value. And I mean, the if kind of doesn't even matter now. I can just make this an if true. So this is going to just use this value of n. It's going to do some computations, and I should get the flag. And I mean, it's still like it's going to.
You can say that. You can say it. Sorry, just.
I have to say. Yeah. Right. And there's your flag. So, I think the important thing with this is sort of just take some time to understand the program before you start doing anything to it. Once you kind of have as much of a good understanding of what you're reversing, it kind of helps. Helps a lot. Yeah. I don't know if Juniper wants to add anything to this. Juniper actually wrote this challenge, not me.
Does anyone have any questions?
Yeah. What's up?
In general,
Mhm.
if we're, I guess, using something like binaries or something like that, would this approach work with editing photos, or if you guys compile it on?
Yeah, that's a good point, and that's actually probably next week's meeting. But yeah, you're right. That if you have a binary, it's a lot harder to change the source. You can still patch binary, so you can go in and edit the bytes in the binary effectively. And if your binary is here's a sequence of instructions that does maybe the same thing as this, right? You could go in and change some of those instructions and kind of make it what you want. Though at that point, in many cases, it's honestly easier to either go into a debugger and run the binary and kind of get values out of it, or you might write some Python code that does the same thing as the binary based on your manual reversing, and that's a lot easier to patch. Yeah, so good question. Okay.